Hey guys, so here's the notes for day 4. We're going to be evaluating logs and finding inverses. Okay, so let's talk about finding inverses. Don't forget, basically an exponential is going to be the inverse of a logarithm and vice versa. I'll put exponentials and logs are inverses of each other. Okay, so that means when we have y equals like b to the x, remember that'll be y equals log base b of x. Okay, so they're just inverses of each other. So here, to find the inverse, now we've talked about how to find inverse functions before. We're going to use that same idea. So always the first step that we need to do is switch x and y. Okay, so to do that, we just now have x equals 6 to the y power. Now what we need to do is solve for y. Now in order to do that, we need to switch forms. So in this case, notice that we are starting off with an exponential. To switch forms, we need to make sure we go into a logarithm, okay? Now, when we do our logarithm, our base b, right? So whatever our base is for exponential, that's going to be the base of the logarithm. So we have log base 6. Now, remember switching our forms. So we do 6 of 6, that's our base, and then we're going to do it of the x. Remember, we don't place these two together. So we have log base 6 of x, and that's going to equal to y, okay? Now, if you're kind of getting confused once again of switching, just remember, oh, I have to have y equals, right? Because when we are thinking about functions, we always have y equals. So that's maybe another way you can think of, okay, if I'm switching my forms, I have to have y equals. Now, from here, if we had anything else to move over, we would have done that. But otherwise, y is all by itself. It's already solved for. So this would be our final answer here. Okay? Okay, let's go ahead and do the next problem. We're going to do the same thing. Now, remember that e and natural log are inverses. So that means when we have e to the x, or I should put y equals, that means that's going to be y equals natural log of x, okay? Now, you will see we have a little bit more here, right? So we do have this plus 3, and that is going to come into a little bit later on when we solve for y. Now, remember, the first thing we always have to do is switch x and y. So now I have x equals natural log of y plus 3. Now notice the y plus 3, that is in parentheses, okay? So remember, we can't take things out of the parentheses, not just yet. So now our next thing is we need to switch forms. We are in natural log, that means we need to switch to our e, the exponential, okay? Now remember, from here, we're going to have e to the, okay? Now we're going to have to the x power, and then equals y plus 3. Because remember, the y needs to be on the other side, okay? It has to have some way so we can solve for it, okay? And we bring along, notice, the y plus 3, because that was in parentheses, and so that came along all together. So from here, we have e to the x equals y plus 3. Now, if we look, do we have y all by itself? No. So what we need to do now is get y by itself. Okay? So sometimes you might have to add or subtract something afterwards to get it. So here, we're going to have e to the x, and then we have the minus 3, excuse me, because I'm going to subtract 3 from both sides. And actually, I'm going to rewrite this so I can show that. So I'm going to subtract 3 from both sides. There we go. So I have e to the x minus 3, and that equals to y. Okay? So remember, you never want to put y if you are changing it into like exponential form. Never put that as the exponent. If you're changing it to logarithm, remember that's going to be on the other side. So it will not be with the log itself. And so since y is all by itself, this would be our final answer here. Okay, let's do the last one. We have y equals 3 to the x plus 2. Okay, once again, remember we know log and exponentials, they're inverses of each other. Now the first step, as always, is to switch x and y. Okay, so now if x equals 3 to the x, and then, 3 to the y plus 2. Okay. Now, before we switch forms, notice we have this plus 2. We really always want to get our base, or the log, all by itself first if we can. So what I'm going to do next is actually subtract 2 from both sides. And so now I have x minus 2 equals 3 to the y power. Now, since my base, 3 to the y, is all by itself, now I can switch forms, okay? I'm going to put this x minus 2 in parentheses since you're going to see why I want to do that. So we switch forms, meaning we need to switch to logarithmic form, okay? Okay, so our base on the exponential is 3. That means the base on our logarithm is 3. Remember, we never put the y where that log is because we need to get y all by itself. So the other thing we have to use is the x minus 2. So notice here that x minus 2 comes all together. That's why in that first part I put it in parentheses so you know we need to put that all together and bring it along when we rewrite. Okay? Then I have equals to y. Now from here we have to see, okay, do we need to move anything else over to get y all by itself? No, it is already all by itself, so this will be our final answer here. Okay? Okay, make sure you watch the next part of the video. We're going to be talking about evaluating logarithms without a calculator.